two of the most bizarre objects in the universe. First, the black hole, an infinitely dense point where gravity traps even light. Second, quantum entanglement, two subatomic particles separated by billions of light-years that instantly know each other's state. In 2013, two physicists proposed that these two physical extremes are the exact same object. To see how that is possible, we have to look at the massive gap at the center of modern physics. On one side, we have Albert Einstein's general relativity. It perfectly calculates gravity, the orbits of planets, and the macro-scale structure of the cosmos. On the other side, we have quantum mechanics. It governs the behavior of subatomic particles, probabilities, and the energy of the extremely small. Both mathematical frameworks are highly successful in their own territory, but when you try to force them together to calculate something like the center of a black hole, the equations break down and produce total nonsense. Bridging these two domains into a single theory of everything is the ultimate prize in physics. The path to bridging that gap started in 1935. Einstein, along with physicist Nathan Rosen, published a paper analyzing the mathematical structure of space itself. They discovered a quirky feature hiding in the math of relativity. Imagine space as a flat sheet of paper. Normally, getting from point A to point B takes time. But if you fold that paper in half and punch a shortcut straight through, you create an Einstein-Rosen bridge. We know this today as a wormhole. The equations allow for a hidden geometric tunnel linking two distinct black holes across vast stretches of the universe. There is a catch to this geometry. Classical Einstein-Rosen wormholes are mathematically highly unstable and collapse too quickly for a ship to travel through. They act as structural geometric links baked into the fabric of space. Now, let's shrink down to the microscopic scale. That exact same year, 1935, Einstein co-authored another paper with Boris Podolsky and Nathan Rosen, the EPR paradox. This one focused on quantum entanglement. When two subatomic particles interact, they share a single quantum state. Send them to opposite sides of the galaxy, and they remain permanently linked. Measure the first particle as spinning up, and the second particle will instantly be found spinning down. The correlation happens immediately, ignoring the cosmic speed limit of light. Einstein mocked this as spooky action at a distance and used it to argue that quantum mechanics was broken. Decades later, experiments testing Bell's theorem proved the math right. That instant connection is entirely real. This leaves us with two isolated phenomena: massive geometric bridges on one side and invisible quantum links on the other. Then, in 2013, physicists Juan Maldacena and Leonard Susskind proposed a solution. Their paper contained a striking equation, ER equals EPR. They theorized that every single pair of entangled particles is physically connected by a microscopic wormhole. These are not just similar concepts. The macroscopic spacetime tunnel and the microscopic quantum thread are the exact same mathematical object, just viewed at different scales. To test this, Maldacena and Susskind applied their theory to a mechanism discovered by Stephen Hawking. He found that black holes actually leak energy. Hawking showed that pairs of entangled particles spontaneously form right at a black hole's event horizon. One falls in, the other escapes into deep space, becoming Hawking radiation. Under the ER equals EPR model, that escaping particle is still physically entangled with the one that fell in. That means the inescapable interior of a black hole is wired directly to the outside universe through trillions of microscopic geometric doors. This leads to three major consequences. Number one, the smooth fabric of spacetime is not a fundamental background. It is a secondary structure that emerges from the dense network of entanglement between quantum particles. Number two, it resolves the famous black hole information paradox. When a black hole eventually evaporates, the information swallowed inside doesn't cease to exist. It travels back out into the cosmos through that massive microscopic wormhole network. Number three, we have a true path to unification. If space-time is built from entanglement, then the laws of quantum mechanics are what directly generates the force of gravity. We no longer have to view reality as a divided, incompatible system. It operates as a single, cohesive quantum geometric web. Start at the smallest possible point of a quantum particle, travel through its geometric tether, and zoom out to the fabric of spacetime itself. You are looking at one continuous structure, which makes the events of 1935 incredibly ironic. Albert Einstein published the defining papers on both of these concepts just months apart, searching desperately for a way to unify physics. He treated entanglement as a mathematical error and wormholes as a quirk of gravity. He had no idea he had accidentally mapped out the exact geometry of quantum mechanics, decades before anyone had the tools to understand it. Black holes, wormholes, entanglement, and spacetime. 4 different names for a single underlying truth. If you want to see exactly how physicists proved that instant quantum connection is real, subscribe and catch our next episode on the math of Bell's theorem.